All right, this is a screencast to walk you through the important points on Module 7, Lesson 2, where we are going to use functions to solve one variable equations. We've actually been solving one variable equations for quite a while, but this is kind of adding a new method for us to solve these. So let's just dive right in, and I'll kind of walk you through some of the things that you need to know as we go. So for example, it says Susan wants to hire a babysitter for the weekend for her 3 children. She has 2 choices. Babysitter A charges $10 per child and $5 per hour. Babysitter B charges $15 per child and $2 per hour. When will they charge the same amount of money? So the whole when will they be charging the same amount, we've actually already done questions like that where you had 2 situations and you had to, put them equal to one another so that you could solve for the variable x or whatever. And we can do that with graphs also. So let's look at A. It says first we want to write and solve a one variable equation to find the number of hours for which the 2 babysitters will charge the same amount of money. We're going to let x represent the number of hours. All right. So babysitter A, the cost of babysitter A is going to be $5 an hour. Okay, so the X is the number of hours, plus $30. Where did I get the $30? Well, because she has 3 kids, and this babysitter is going to charge $10 per child, so that's a flat rate of $30 because she's got 3 kids, and then the babysitter is going to charge $5 an hour. Babysitter B is going to charge $15 per kid, so that's going to be a flat rate of $45 because there's 3 children, and then charge for $2 an hour. Okay, so if I put that in the form of an equation, my first babysitter I'm going to say is f of x, and the equation will be 5x plus 30. My second babysitter, I'm going to call that g of x, and her equation will be 2x plus 45. Okay, so write a function for each babysitting service. That's what I actually did in the little bubble. And then it says to enter the 2 functions in the graphing calculator. So I'm going to show you a variety of ways of solving this problem, this particular situation. Okay, the first method that we're going to do is using a graphing calculator. Okay, so I have a table down here. We've been using the little y equals button on our graphing calculator, and that's what we're going to use in just a second. Our first equation we'll type in as y1. Our second equation we'll type in as y2. And we're going to look where those 2 lines cross, where they intersect on the graph, because that will be the point where the cost is the same. All right, let me grab my calculator and I'll show you what I mean. Okay, so first turn on my calculator. And I'm going to go to y equals. I'm going to type in 5x plus 30 for the first equation. I'm going to type in 2x plus 45 for the second equation. Now, on this particular problem, where they intersect is not going to be in the normal window if you keep the window settings just from -10 to +10. So what I did is I went and changed my window settings, which you might need to do too, because the default is like -10 to +10, -10 to +10. And that's not going to be enough. Your graph's not going to be big enough. So I would just say change it to -100 to +100 for both the x and the y. And then the other stuff is you can keep the same. Okay, so change your window settings if you need to. And then once you've done that, hit the graph button. And there are your 2 graph lines. If you hit the second function button and then the graph, the second function of that button is a table. So hit second graph, and it gives you the table of values. When x is 0, just like on your paper, y1 has a value of 30 and y2 has a value of 45. When x is 1, meaning 1 hour of babysitting, your y value for the first babysitter, babysitter A is 35, and babysitter B is 47. For 2 hours of babysitting, babysitter A would charge 40, babysitter B would charge 49. Okay, so I'm getting all these numbers just by reading this table. How did I get that table? By hitting the second function and the graph button, because the second function of that button is a table. Okay, so use that to fill in this table that they gave you. Okay, do that real quickly. Okay, so now that you've got your table filled in, you can definitely see that for 5 hours of babysitting, the cost for each babysitter would be the same. They would both charge $55, which is where those two lines are intersecting. I can see the intersection here, although the little marks on the graph are a little bit hard to see. But I can also see, based on the table that it produces, that at 5 hours they're both charging $55. Also, go to the trace button, and if I put in a 0 and hit enter, then it's going to tell me that the y is 30 when the x is 0 for the first value, for the first graph. Okay. When x is 5, my y value is 55, which is what it should be. Okay. Okay, and you notice that up here it's giving you the equation for the first line. If I just hit this up arrow, then it switches to the equation for the second line. And then if I just enter 5, that's telling it I want the information for when x equals 5. So hit 5 and then hit enter. And it'll tell you that also for that equation, when x is 5, y is equal to 55. Okay, so that's using the graphing calculator to do this and see where the lines intersect. But we can also do this without a calculator, and that's what we're going to do next. Okay, so I'm going to move over here and use this little spare area on page 326 to do the same thing, but with a different method. We're just going to use our brain this time. Okay, remember, we're trying to figure out when the babysitters are going to be charging the same amount of money. So when is what babysitter A charges, when is that equal to what babysitter B charges? So I can set them equal to each other and solve for x. All right, I'm going to move the 2x to the other side of the equal sign by subtracting. After I do that, I have 3x plus 30 equals 45. Then I'm going to move the 30 to the other side of the equal sign by subtracting. And I get 3x equals 15. Divide both sides by 3. And I get x equals 5. Which is what I got when I did the same thing on the graphing calculator. The place where the two lines intersected was at x equals 5. Okay, I can also do this and graph it by hand using the two equations, that I got, and they just so happen to be in slope-intercept form already. So I can just take those and plot points. So for instance, the pink one is the cost for babysitter A. So let me plot that real quickly. Okay, so the first one for babysitter A, y-intercept is 30, because that's basically your one-time cost. And then she's going to charge you $5 an hour. So there's the line that's created from that equation. So the next one is 2x plus 45. That's for the second babysitter. So let me plot that one. So the y-intercept is going to be higher, but the slope is going to be flatter. So hang on. Okay, so I've plotted the graph for babysitter B. And you can see that babysitter A and babysitter B, if I plot both of those lines, the lines intersect at x equals 5, which is what we solved for. So we did it actually 3 methods. We used the graphing calculator. We just plain old used our brain and set the two equations equal to one another. And we did old-fashioned graphing. And if you would like to borrow a Post-it note graph paper sticky and do that and just stick it in the lesson right here, just see me and I'll be happy to give you one of those.